Okay. Now, using these functions, we will build our neural network model. Sorry, deep learning model. All right. Okay. Now, CNN is equal to sequential. CNN dot add CNN dot add convolution 2D open bracket 32 comma 3 comma 3 by 3 filter comma activation is equal to value comma input underscore shape is equal to 256 comma 256 comma 3 comma padding is equal to same. Padding is equal to same. Okay, so this is our first convolution layer. Then CNN dot add batch normalization. Normalize the entire batch. Normalization means min-max scaling. Normalizing means min-max scaling. Then CNN dot add dropout (0.20) 20% features dropout. CNN dot add again a convolution 2D. Again 32 3 by 3 kernel. Activation is equal to ReLU, comma padding is equal to same. CNN dot add dropout 0.20 20% features dropout. Then CNN dot add convolution. Sorry, why is this? Convolution 2D open bracket 24 comma 3 comma 3 comma activation is equal to ReLU comma padding is equal to same. Then we'll add one more convolution layer. CNN dot add convolution 2D 64 filter comma 3 by 3 kernel comma activation is equal to ReLU comma padding is equal to same. Okay. Then CNN dot add max pool 2D pool and pool underscore size pool underscore size is equal to 2 comma 2. CNN dot add dropout 0.20. CNN dot add flatten. CNN dot add dense 128 neurons. activation is equal to ReLU and dot add dropout .30, 30% dropout, CNN dot add lengths 2, comma, activation is equal to sigmoid. CNN dot summary.
Sir, mail this code for us, sir.
Let me run. Let me see if there is an error. Accordingly, I'll mail. I'll put it in the
Okay,
chat
sir.
window. Let me check if there is any errors. Taking a lot of time to execute. So I pasted the code in the chat window. Just check it once. Yeah, I'm calling from 5 to 9. Can you send me some tea? Yeah. Regular tea, regular tea. One, yeah. Yes. Positional, got this error. See, which line it is pointing the error? Just check in the code, it will point to some line.
Batch normalization.
Batch normalization, huh? But batch normalization is correct only. Why it is giving?
They're in line 2, sir.
That's what, batch normalization is correct only, right?
No, up.
22, 1, 2.
సార్ ఏదైనా పొజిషనల్ ఆర్గ్యుమెంట్ ఏమైనా మిస్ అవుతున్నాం చూడండి ఒకసారి.
Oh, yes. Nandakishore, you are right. Add input is equal to, I forgot input underscore shape is equal to. Now it is clear, all of you? Okay, you have to compile also. CNN.compile loss is equal to binary underscore cross entropy. Now you are not getting an error, right? And then CNN.fit x underscore train comma box is equal to 10. You guys run this, okay? Mine CNN is still running. I don't know why it is running so much time. Recording all things, slowing the network. These are the last two commands to run. Once you run these commands, you should start building the, your model should start running. Okay, then do one thing. Dense is equal to 1. Make it dense 1, not 2. In the last layer, na, in the CNN dense last layer, activate 1 activation is equal to sigmoid. Correct the model. This is the change. Rerun the CNN one more time and run it. Is it running, participants?
Yes, sir.
What is the first time layer time? Can anybody tell me what is the time, how much time it is taking? Yeah, it will take 3 minutes, yes. Because this is a very large model, na? Let it run.
Sir, I got an error
What error?
while fitting the train data, sir. Int object is not iterable. Like that, sir. Binary cross interpolate.
Let me check your, give me your Anydesk number.
Okay, sir. Once I am checking myself, I will.
Please check, na? Other people it's running?
Yes, sir, it is running.
Yeah, okay. మమ్మీ హలో అయిపోయింది.
Compile epoch epochs equal to 10 seconds.
Auntie, breakfast item now. Get somebody.
Oh, memory error. I got a memory error. Meanwhile, you can take a break, participants. It will take time to run, okay?
Okay, sir.
All of you are running it, right? I think one epoch is 3 minutes, right?
Yes, sir. More than 3 minutes.
Yeah, because this is a real-time large data, so we have to bear with it, okay?
Okay, okay.
అరుణ్ బ్రేక్ఫాస్ట్ చేయి ఇంకా.
ఏంద్రా అందుకే ఏమన్నా వినపడింది.
సంతోష్ నువ్వు చేసినావా?
బ్రష్
వివేక్. ఏ శర్మాజీ అన్నది.
చేస్తున్నావు?
Okay, guys, you got the model? So guys, you are there?
Yes, sir.
Yes, sir.
So you got an accuracy of around 50%. Nandakishore got 93.19. Santosh, how you got only 50%? So how to choose the number of neurons, number of hidden layers and nodes in a feed forward neural network? This is one of the important thing which you need to understand. So for hidden layers, how do we optimize? How do we look at them? This is where we can see here. So see here. This is the formula which some people use to decide the number of neurons. But this is just a rule of thumb or something like that. But this is not a statistically proven formula also. So number of neurons in hidden layer is equal to number of samples in training data set divided by an arbitrary scaling factor, usually between 2 to 10, into number of input neurons plus number of output neurons. Some people say alpha between 2 to 10, some people say alpha between 5 and 10. But this is the only formula I think I have found to decide the number of neurons in a hidden layer. Okay, so generally we run multiple what you call models with multiple neurons, and there's this thing. So this is one formula where you can look at it. I'll put this link in the chat window. You guys take a look at it. This is one way of looking at how to decide the number of neurons. And for hidden layer, how to decide, see here. See, the number of hidden neurons should be between the size of the input layer and the size of the output layer. The number of hidden neurons should be 2/3 the size of the input layer plus the size of the output layer. So these are all random ways of looking at it. There are no fixed rules. Generally, what we do is based on the predefined model, we will do the adjustment. We will do the adjustment or based on the predefined model like CNN. Okay, in TensorFlow website, you will see a CNN standardized model. We will take that CNN model and we will run the standardized model and see how it works. If it is giving accuracy, it's okay. If it is not giving accuracy, then we will add convolution layers. Depending upon the requirement, you can add neural network layers. But in image processing, adding convolution layers and dropping out the features will be better option rather than increasing the hidden layers in a what you call the dense layers or in the neural network. So that is how you have to look at it. So whenever you do a convolution layer, add padding, and also you should reduce the variable the input weights by adding dropout. So how do we reduce the what you call input weights? Now the model which we ran is 1 crore 34 lakh, right? It's a very large model. 1 crore weights means you can imagine how much time it will take to compute, correct, and all those things. So you have to bring the number of weights to a manageable level by adding dropout at each layer, so that you can remove the noisy features by using the dropouts. Okay, so this is the way I can find regarding the hidden layers and neurons. Did you guys come across anything similar to like this? Guys, you are there?
Yes, sir.
So the building of neural networks is more of like trial and error only, based on working on a predefined model and then adjusting it based on our requirement. Now there are a lot of research which are new models are being created. Temporal convolution network is one model which is being developed for satellite imagery and all. So there are new types of models which are being developed and which are gaining approval from the community. Once the model gets approval from the community, it will be added as a code in the TensorFlow and the Keras. So there are, I heard around 8 to 10 models which are being tested to be added to the TensorFlow network, TCN model, temporal convolution network model. There are different, lot of research is being done in American and Western universities on neural networks. So as and when their models get approved, and once the testing process is done in Python, once it generates good results, then it will be added to the network, the TensorFlow library as a function, and then we can use it in our models. Any doubts, participants?
Sir, one see my code, sir. I will share any desk number. Actually, Ashita got 90% accuracy, sir, but my accuracy is not improved.
All of them will get 90% above. Even I got 93 or something when I ran it. Because of the internet problem, I am not able to run it, but you will get more than 90%. That is damn sure.
Sir, I got 50, sir. Not accuracy is not improved by
No, that means you forgot some parameter. Show me your code. Give me your AnyDesk number.
I'm texting, sir. Once.
And participants, you are completing the in-house exercises. You have any doubts in in-house class exercises? Sorry, in-class exercises.
Sir, please check, sir, once. Sir. This
Hmm.
one.
Please accept the connection request. See, this flow directory code, you have not added additional commands. Now you got it, Santosh?
Yes, sir. Thank you, sir.
Hmm. Any other participant is having issues? All right. So I want you guys to build a house price prediction. You remember? I want you guys to build a neural network for house price prediction. Did you guys build it? Deep learning? Okay, guys, any doubts? Participants? So Santosh, it's now 90%, right?
Yes, sir. 95 something. Sir.
End of the model, it will be somewhere around 93 or 90. Between 93 and 94 is what I got when I ran
Oh,
it on
okay.
Kaggle. So now you guys know how to run the model on Kaggle also, right? So Google Colab and Kaggle are two important resources for running GPU based models. If you want to run a GPU based model, the only option is Kaggle and Colab. Colab is only Python, but whereas in Kaggle, you can also have R also. R and Python both are there in Kaggle. Whereas in case of Colab, it is only Python.
Sir, here we are giving an extra comments by loading the data. Sir, in Google Colab also we need to do this.
Same, you can upload the images into your folder. First, you have to download the images from Kaggle. Okay.
Okay, sir.
Then you have the Colab, right? If you go to Google Colab, because my internet is very slow, I'm not able to do it.
Okay, sir.
So
These arguments are target size, batch size, class mode, all those.
same thing, everything is same. Only thing is the path of the folder you have to give. See, you remember Google left side, you see a folder.
Yes, sir.
You have to upload the data into that folder. Again, there is a 3 dots there. You get the path of the file and you put it in the image data generator.
Okay, sir.
Yes.
Same command, nothing more different. Only thing is the input data. First, you need to upload into the what you call
Folder.
that folder into the left side. When you see the folder on Google Colab left side, see this folder you have to upload. First, you have to upload the data into this folder, or you can use it in your Google Drive also, right? You remember Google Colab Drive?
Yeah, we'll mount the.
So that 1.24 GB images you download from Kaggle, either you upload in using this upload into this and you get the path. Okay, you copy the path and you put it in the flow directory, and then rest of all commands are absolutely same. And compared to Kaggle, Google Colab runs little bit faster. So the Google Colab runs a little bit faster than Kaggle. So you can try the exactly same commands. Only thing is the flow directory images will first you need to upload the images into this folder. You also have to do the test images also. Our test data is also given there, right? In the epoch only you can give validation is equal to x underscore test by converting the data test data also into the same format as your X train, and then you run the model, you will get the accuracy on X test also.
Sir, where you are uploading that Monday's recording session in LMS, sir?
Not LMS. I don't have access to LMS. Earlier, I have sent you the Google Drive link. Just check my email IDs. You'll see a Google Drive link for PJ17.
Okay, sir.
I will send it again today. I will send it again today because what is happening is because of that upload and all, my internet is becoming very, very slow. It is showing full signal here, but somehow it is not able to give us the full coverage. That is the problem. So, guys, will you make the, give me that 5 minutes presentation for your models that you can do? Since we are not able
Yeah,
to.
yeah, sir.
That I will anyway, we will record those sessions. So 5 minutes are things you have already made, right? So each one of you start it, and then you can have the recording also as a reference for your interviews and all. Okay.
Okay, sir.
Okay, sir.
So who will start?